Hello, welcome to another physics video. Today we're going to be talking about the base units. Um, and this is going to be very important throughout the entire study of physics. So this can be seen as like the first video in the physics series. So in order to make measurements, we have to use quantities, and we also have to use uh, units. We have to, like in our everyday life, we differentiate between inches and feet in our American system, where 12 inches is equal to 1 foot. And so we're going to be looking at the SI units. And these ones are going to be the ones that we'll use to study physics. And we'll see why as we go through our study. So what we're going to discuss in this video are base units. We're also going to study derived units, and we are going to study the metric prefixes. We'll go over all of these. So any quantity that you write in your equations in physics is going to have units, it'll have a quantity, and it'll have a metric prefix. So we'll start just by listing the 7 base units. So let's say we'll call this column quantity SI base unit. This will be our second column. There will be a symbol associated with that unit, and then I'll give an example where these would be used. Okay, so the first quantity we're going to list is for length. I do this in a different color. And the unit that we use for length is the meter. And the symbol for the meter is a lowercase m. And this is used to describe height or distance, or maybe how much an object has been displaced, how much it has moved from some starting position. The next unit is mass. This is like the amount of matter that is in some, it's like the amount of matter that comprises an object. And the unit for that is kilogram. So mass is measured in kilograms, and the symbol for the kilogram is kg. And this is basically the amount of matter in an object, the mass of an object. The measure of the amount of matter that the object contains. The next one we should all be very familiar with, time. We use seconds. Got my columns mixed up here. So we'll use the second as our unit for time with the symbol S. And this is just used to measure the duration of some process. Could be used to measure the duration of some object being displaced through some amount of time, right? And then, so we'll be mainly focused on these ones to start, but I'll quickly fire off the rest of them. We have electrical current, and this is in units of amperes. I keep doing this. This is somebody's name, so we capitalize it. And this is just used for the current in a circuit. Next one is temperature. There are different temperature scales, but right now I'm just going to use the one in SI, which is Kelvin, and that is capital K, named after Lord Kelvin. It is the thermodynamic temperature, so it is a relation to absolute zero, the coldest anything can be. Other temperature scales, they mean the same things, but they have different starting and ending points and are based on the boiling point of water, for example. The amount of a substance is given by the mole. You'll see this a lot in chemistry, but this is given by the mole, and the symbol for this is lowercase mol. Basically the number of particles. And then luminous intensity. This is one that we're probably not very familiar with, but you can actually see these units on your hardware at a hardware store in the light bulb section, or if you're buying a floodlight or something. And so this is measured in candelas, and this is lowercase cd is the symbol, and it's basically just the brightness of some light source. And so those are the foundational units that pretty much make up everything that we'll see in physics. There are now, so these are all the base units, right? So we've got that checked off. Derived units, what does that mean? Well, so for example, what if we want to measure the speed of something? We don't have a unit for speed. So, but what we can do is combine units, right? Like when you are in your car and the speedometer says kilometers per hour or miles per hour, that's a unit of length divided by time, right? It's the amount of displacement in some amount of time that will tell you how fast you're going. And so, for example, I will write velocity, which is typically lowercase v, is the symbol we use. And I'll just write this out. Velocity, I just said, is the length per unit time. So the amount of displacement over some time is a good example. What are the units of length and time? Well, for length, it's meter, and for time, it's second. And since we have length over time, we can say that this has units of meters per second. So this means that the unit for velocity is a derived unit. Now, there's something else we can talk about. I did mention kilometers, right? But we have meters here. So what does the kilo mean at the beginning? Well, that's called a metric prefix. And so like a kilometer can be written out like this, and kilo is the metric prefix that tells us how many there are. And so I'm just going to make a quick table here, and we'll go through all of the common metric prefixes that you'll typically see in a physics course. So let's start with the base unit. And I'm actually going to do this from the middle because it'll show it better. So we're going to say that this is going to be the large side. And then how many will there be? About 13. So start about right here. So, okay, the base unit, it's going, remember I said the metric prefix just tells you how many of the base unit there are. Okay, so for the base unit, we have no symbol for that. And this just means that it is 10 to the 0 power of those things. 10 to the 0, the decimal representation of that number is just 1. Okay, and this will start to make more sense as I continue. Let's go up in size. So let's say that now we have 10 meters. Well, this is the metric prefix deca, and the symbol is D, and this is 10 to the 1 of the base unit. So if we have decameters, we have 10 meters, 10 to the 1 meters, which the decimal number is this. And I'm just going to continue going on upwards. If we have 100 of a base unit, the metric prefixes is going to be hecto. I should write dashes so that we know it's a prefix. And this is just going to be a lowercase h, 10 to the 2. And you can see as we go 10 to the 3. Right here, though, it's going to change. So this is kilo, as we already discussed, 1,000 of something. And the metric prefix is K. This is 100, and this is 1,000. Continuing on. So from here, we basically just start skipping every third order of magnitude. By order of magnitude, I'm talking about this number right here. So if I'm now going to count up by threes for our metric system, we're going to end up at 10 to the 6, and this is going to be mega. Okay, and that metric prefix is going to be a capital M. The next one, 10 to the 9, now we're going by 3 orders of magnitude, right? We went from 3, 6 to 9. And then you can probably guess what the next one is going to be as well. But this one is giga, and this is notated with a capital G. The next one is tera at 10 to the 12. And these are for like astronomical quantities, obviously. The symbol for that is capital T. And then if I write these out, and let's, now that we've covered all the ones that are larger than the base unit, let's now go down in scale. Let's go to the realm of the very small. So if we have 1/10, or in other words, 10 to the negative 1 of a unit, this is going to be deci, chopped into 10 pieces. And the unit for that one is going to be D. And sorry, deca is DA. Deci is just lowercase d. And then this is just 1/10 or 0.1. Going down further, we're probably all familiar with the centimeter. And so this is going to be 1/100th, and we know that the metric prefix is going to be C. So centimeters is cm, where m is your base unit, C is your metric prefix. And we do the same thing once we get to the third order of magnitude. We then just start skipping by orders of magnitude, every third order of magnitude. So it goes milli is the 10 to the negative 3, or 0.001 of some base unit. And then micro is going to be notated with this symbol, and then 10 to the negative 6. So now we're getting into pretty small territory. The next one is nano. And now that we're skipping by orders of magnitude of 3, this lowercase n indicates that there's 10 to the negative 9 of some base unit. Next up, we have pico, and this will be the last one. Most quantities are going to fall in this range that we've listed. This is just a lowercase p. And 10 to the negative 12 as a decimal number is just this. Okay, so these are our metric prefixes. You might want to take a screenshot of that. You can also find many tables on a Google search or any other way that you would like to find them on the internet. Now, just to do some examples here to drive this home a little bit, like we see like a lot of length units, and so I just want to do some examples here with the length units. So how many meters in a kilometer? Well, we have kilo, right? So that means 1,000 meter. Here's our symbol, and this just means 1,000 meters. So if we just had regular meters, we can write this like 10 to the 0 meter, because 10 to the 0 is just 1. A millimeter. What's our metric prefix symbol for that? It was lowercase m, right? So this can be a little confusing if you're not clean with your work, because notice we also have m was the symbol for mass, and now we have the metric prefix symbol for milli, and we also have meter, which is also denoted by lowercase m. So this can get confusing if you're not clean with your work. What's the quantity of meters in 1 millimeter? It's 10 to the negative 3 meters. Okay, remember, 10 to the negative 3, that equals 1 over 10 to the positive 3, and 10 to the positive 3 just equals 1,000, right? So therefore, milli means 1 over 1,000, or 10 to the negative 3 is a more compact way that we write that using scientific notation. And we do the same thing with units of mass. So we have like a kilogram, that's just going to be equal to 1,000 grams. More compact way to write this is to say 1 kilogram equals 1,000 grams. And we just use the symbols and the quantities. So notice each of these quantities has a magnitude and a unit attached to it. Without units, our problem becomes meaningless. And it also helps us greatly in solving the equations of motion, for example, which we're going to take a look at here very shortly. And I think that I'll wrap this up for right now. I don't think that we need to go into moles and temperature. I think we can save that for a different subject. But for now, I will wrap this video up. So thank you for viewing. If there's anything you would like me to clarify, please just leave it in the comments. And also, if there's anything you would like me to cover in the future, leave that in the comments as well, and I would be happy to oblige. Thank you for viewing. Have a wonderful day.